Welcome everyone, let's learn a new topic. Have you ever wondered what an AI agent is actually doing behind the scenes? It's not just talking to an AI model, it's calling APIs, searching the web, reading databases, and waiting for responses all at once. But if one task gets stuck, the entire system can suddenly feel slow and unresponsive. That's exactly why learning async programming, especially async IO and threading, is one of the most important skills you'll need as an AI agent engineer. Here's something surprising. Most AI systems are actually spending more time waiting than thinking. They wait for API responses, databases, files, and external tools. And during all that waiting, your CPU is simply doing nothing. If your program executes these tasks one by one, everything becomes slow and inefficient. This waiting problem is called IO bound work, and async programming is designed to solve exactly that. Think about this like you're standing in a supermarket queue. Instead of standing there doing absolutely nothing, you decide to finish another small task while waiting. That's exactly how async programming works. Your application doesn't sit idle, it switches to other work. In Python, we mainly solve this using async IO, which uses an event loop, and threading, which uses multiple threads, and both are designed to handle waiting more efficiently. So, what exactly is async IO? Think of it as a smart traffic controller inside your Python application that keeps tasks moving instead of letting them wait and block everything else. It uses concepts like event loops, coroutines, and async tasks to coordinate work efficiently, which is why it's heavily used in AI agents, fast API applications, streaming systems, and LLM orchestration. If you are building modern AI applications, Async IO is one of those foundational tools you'll use again and again. The easiest way to understand an event loop is to imagine a restaurant manager. If one chef is waiting for a pizza to bake, the manager doesn't let that chef stand around doing nothing. They immediately assign another task. That's exactly what the event loop does inside Python. It keeps switching between tasks, pauses the ones that are waiting, and comes back to them later. This is how applications stay efficient without creating lots of extra threads. Now let's see what an actual async program looks like. There are only four keywords you need to remember. Async diff creates an async function. Await tells Python to pause and wait without stopping everything else. Async io.sleep is a non-blocking pause, and async io.run starts the whole async system. This is incredibly important for AI agents because they're constantly waiting for LLMs, APIs, and external tools. Instead of freezing during that wait, Python can switch to other useful work like monitoring sensors, handling another agent, or streaming responses. This is where async programming starts to feel magical. Instead of waiting for one task to finish before starting another, Python can schedule multiple tasks and let them run during each other's waiting time. That's exactly what asyncio.create underscore task function does. And this is the same idea behind modern multi-agent systems, where several agents work together without getting in each other's way. So far, we've seen how async IO uses one event loop to manage many tasks, but Python has another approach called threading. Instead of having one coordinator switching between tasks, threading creates multiple workers called threads that can work concurrently inside the same application. Think of it as having several employees working in parallel instead of one manager assigning jobs. Now, the big question is when should you use async IO and when should you use threading? Use async IO when your application spends lots of time waiting for things like APIs, AI models, network requests, or streaming data because it scales extremely well. Use threading when you're working with older blocking libraries, unsupported SDKs, background monitoring, or smaller applications where simplicity matters. A good rule of thumb is async IO for modern AI systems and threading for blocking or simpler tasks. Before we finish, let's talk about four mistakes almost every beginner makes. First, never use time.sleep inside async code because it freezes the entire event loop. Use await async io.sleep instead. Second, don't forget await, otherwise your coroutine won't run properly. And avoid mixing async code with blocking libraries or creating too many threads because that can make your application slower and harder to manage. Remember the simple rule: don't make a program wait unnecessarily. Let it stay productive while it's waiting. That's the mindset behind modern AI systems and one of the superpowers of an AI agent engineer. Follow to learn more. Thank you.